So today we are going to kind of formalize a construction that we've been using, but we're going to put it some details to it and make sure that we understand what this tool can do and dig a little bit deeper into its understanding. Now, it goes a little slow because it's not just about can you do the construction. It's more about can you understand what's behind the construction so that you can then use the tool in different ways. That's what we're going to be looking at today. So we're going to start here with this first line segment up here on the upper left. And we're going to be writing some information up at the top here and down the bottom here. But the first thing we're going to do is we're going to do this construction that we've been doing where we've been arcing to one side of the line and arcing to the other side of the line. So let's set our pointer here at the end of our line segment. And then let's open our compass here clearly more than halfway, but not too far. We don't want to go too big with this, but clearly more than halfway. And then we want to lock that compass setting down so that we have it secured. And then we're going to arc above our line segment, and then we're going to come down here and we're going to arc below our line segment like that. Then we're going to flip our compass over to the other side. And we're going to arc above our line segment, and we're going to arc below our line segment like that. And what I've been telling you all along is that we have these two intersection points now that we can use to line up our rulers with. And again, you want to try to be as precise as you can with this. So, good thing is to put your pencil where you want it, then kind of just move your ruler up to that, check it on the other side, make sure your pencil's going to go where you want it to go, and adjust the ruler to your pencil. And then you can draw your line through the middle. Okay? And what that did for us was take this existing line segment and bisect it, right? We constructed a segment bisector. And we could check that in a couple different ways, right? We could take our compass and we could just change our setting here to the middle. And then we could just move our compass over here to see that we've got the same distance on this side. Or go ahead, use your ruler and let's get an actual measurement of how long in centimeters this line segment was. The original line segment, how long was it in centimeters? So you take your ruler and you line it up on there. And you should be able to see that that line segment was 4 centimeters long. And your segment bisector line goes right down the middle at 2 centimeters, doesn't it? Yeah. So we effectively used this arcing on one side, arcing on the other side. And the whole idea was that we had this same distance that we were using on both sides to find that middle point. Now, this is a construction we've been doing. We did this several times in our building of segments, but we want to look a little bit deeper at this tool to see if we can understand some things about it. Okay, so let's, we're going to take some notes on this right up here. So we're going to say that this construction, this arcing to one side and arcing to the other side with the same distance, can be used for ... And then I want you to draw just kind of a little arrow down here like this. And we're going to make some points about what this can be used for. Well, number one, this can be used to bisect a segment. Right? So if I want to take a segment and I want to cut it into 2 equal parts, that's what bisect means. I can use this construction where I set my compass opening more than halfway. It doesn't have to be the entire length of the line segment. It's just anything more than halfway, right? Another thing that we can use this for is to find a midpoint. All right, we can find a midpoint. And really, this one construction does these two things just in one swoop, right? Because it bisects the original line segment, cuts into 2 parts. And where does it cut into 2 parts? Well, it cuts it into 2 parts right here, which is the midpoint, right? Now, the reason why I specify the difference between these two is because I'm going to ask you to do these two instructions a little bit differently. Right, Carlos? Okay. So when I ask you to bisect a segment, what I'm going to want to see is your arcing constructions and then your line all the way through bisecting that segment. But when I ask you to find a midpoint, We're going to use the same construction. We're just not going to draw this line all the way through here. We're just going to mark the midpoint. And there's a reason for that. When we get a little bit deeper into this, you'll see why. Okay, but for right now, let's take this second one right here. And what I'd like you to do is I'd like you to find the midpoint of this line segment right here, which means you're not going to draw the line all the way through. You're just going to identify the midpoint, but you're going to use the same construction. Okay, let's see what you can do. All right, go ahead.
So we're not drawing.
You're not drawing the bisecting line. Yeah, you're just going to use your ruler to find the midpoint. You're still going to have to line your ruler up to the two intersections, right? But you're only going to mark the midpoint. So if you're not sure, I'll do this one with you if you're not sure. But I'm going to start by putting my pointer at one end of my line segment. And then I'm going to open it up clearly more than halfway, lock myself down. And then I'm going to arc to one side, like up here. And then I'm going to arc to another side, like down here. I'm going to switch over to the other side here, put my pointer down, and then I'm going to cross arc, and I'm going to cross arc so that I get my two crossing arcs. And then I'm going to take my ruler, and I'm going to line up my two intersections, and I'm going to even put my pencil where I want my pencil to go, just so that I make sure that my ruler's in the place where I want it to be. Okay, like that. But this time I'm not going to draw the line all the way through. I'm just going to put a little mark right there to identify this point as the midpoint. See the difference? Here, I bisected the segment. Here, I identified the midpoint. Now, there's a reason why we're going to do this, like I said, okay? You'll have to wait on that one, but there's a reason why I want you to be able to bisect the segment versus just find a midpoint, okay? All right, everybody good so far? Easy enough, you know what I'm looking for? Okay, so here's what I want you to do. On this example right here, I want you to find the midpoint, so write that down. And on this example right here, I want you to bisect the segment. Okay, so you're going to do those two examples. You're going to find the midpoint on the example on the left, and then you're going to bisect the segment in the example on the right. Go ahead. Here's what you should have come up with right there. Hooray! Good? Okay, so we've got this construction that helps us find the middle of a line, helps us bisect a line. Grab your protractor tool.
What's that? Oh, that's mine.
Now, again, remember, if we want to measure an angle with our protractor, right? So you can see here I've got this little T intersection on my protractor. If I want to measure an angle, that's my vertex. And then I line this baseline here on my protractor up along one of the sides of my angle. Right? So if I wanted to measure this angle right here, I would take my protractor and I would fly it in like this, right there. Line it up. And how big is that angle that we made? 90 degrees, right? So we can mark that with a 90-degree marker. Girls, you're going to need one of these homeworks right here. No, that's the one over that.
Oh, my ruler's right here.
There you go. Fantastic. Okay, now check it out. How about this one down here? Let's take our protractor and measure. Let's say we measure this space in here right here. So this is the angle we want to measure here. Okay, so I'm going to take my protractor and I'm going to rotate it around and I'm going to line it up. What do I get? 90 degrees, huh? Okay. Let's do this. Let's take this one and let's just take the straight edge of our protractor for a second here. Line it up on your arcs here. Okay, line your protractor up on your arcs. And then here's what I want you to do. We're just going to do a couple of dashes along the straight line like that. See how I did a couple dashes? Here, let me zoom in for you. So I did some dashes there like that. So I just took my straight edge part of my protractor. I put some dashes. Dashes are kind of a way in geometry for us to say it's there, but it's not really there. You know what I mean? Like we can see it. But it's enough there that if I took that and I lined my protractor up on it, you could again see I have another 90-degree angle, huh? And the same thing goes here. Let's put some dashes on this one down here. So I put some dashes down here as well. And I can measure any of these angles, right? Because I've got 90s all the way around, huh? Like that. All right, so there's a third thing we can put on our notes here that this construction does for us. We can use this construction. It's good for making a what kind of segment? What does that symbol mean? This is good for making a what segment? It's got a special word. No, not congruent.
Perpendicular.
Perpendicular, right? Which means it meets at 90 degrees, right? Got to know that word. If you don't know that word, make sure you know that word, okay? So this construction does three things for us. It bisects a segment, it helps us find the midpoint, and it creates a 90-degree angle all in one swoop all the way around. Okay, so with one construction, we can do three important things. All right? Good so far? Okay. Now let's dig in a little bit deeper into this construction down here on the bottom of our paper. So what I want you to do is take this part of your paper and just kind of divide it down like that, little squiggle. If you want to do a straight line. I like squiggles. Now listen. This construction right here has a special name. Ready? I'm waiting for the guys in the back who aren't paying attention. Okay, this construction has a special name. It's called the perpendicular bisector. Kind of makes sense, right? Bisects at 90 degrees, perpendicular bisector. Well, we have something called the perpendicular bisector theorem. Let's write this down. Perpendicular bisector theorem. Now, one of the things that I'm a fan of in my teaching of math is connecting the idea of words or numbers or variables with a visual, right? And I like to think of it as like a coin. Think about a quarter for a second, right? You have two sides to a quarter. You got the head side, you got the tail side. They look different, same coin. Okay, same thing here. We're going to have some words that describes this perpendicular bisector theorem, but we're also going to have a visual over here that helps us connect these two together. Same thing, two different sides of the same coin. So we're going to put it in words, and we're going to draw a picture of it, and hopefully that will give you a good understanding of this perpendicular bisector theorem, because it's critical in your project coming up that you're able to use this construction in a couple of different ways, okay, as needed. Same construction, but you got to use it differently at different times. Okay, and so that's what I need you to be able to take out of today's lesson is when do I use this in what way at what time? Okay, so let's start with this. We're going to take this line segment here and we're going to put our pointer down here at this line segment, and then let's open up fairly large on our compass setting. In fact, we want to be able to just stay within the bottom of our paper and the top of our paper here. And then we're going to do a perpendicular bisector construction on this line. Perpendicular bisector construction. Ready, go. So I asked you to do a perpendicular bisector construction. I didn't ask you to find a midpoint, right? I should do the perpendicular bisector construction. So that means you're going to do the full construction here like this. Okay? All right, now let's put some points on our line so we can talk about some things a little bit more specifically. Okay, so I'm going to call this end of our original line segment A, this end of B. I'm going to call this intersection point C, which is what? C is what of A and B? That's the midpoint, right? Okay, good, we know that. All right, and then let's call this intersection of the arcs and that line up there F, and let's call this one I. Now, this is really important that you start to catch what I'm going to teach you here, okay? Watch. You'll notice that I made intersection F up here by using this compass opening right here, right? Now, I could have drawn a whole circle all the way around here, but I didn't. But it's there, right? We just don't see it. Everybody good with the whole circle? And that makes this distance a radius of this whole circle that I'm drawing here. It also makes this distance right here a radius. And all radiuses of a circle have the same measurement, right? So that means that the distance from A to F in a straight line here is going to be the same as the distance from A to I. But also, we use the same compass setting from the other side, right? So that means the distance from B to F is a radius of the same size, just like it is from B to I. Did you see that? Okay, so these straight lines are radiuses from my pencil tip to the pointer. That distance is going to be the same here and here. Okay. All right, let's put our pointer at A again. And this time, let's shorten our opening to less than what we had, but not too close to the halfway mark. Let's do another perpendicular bisector construction with that opening. Ready, go. All right, good. You should have done that. And they both got back to the same line, right? Now, we've seen this already, but we haven't really studied it, and that's what we're doing today. Let's name this E, and let's name this H. Now, again, watch this real quick. Important you see this. The distance from A to E is a radius of a circle that we could have drawn in here, right? And that A to E distance is the same there as it is there because we use the same measurement of the compass. Likewise, down the bottom here, B to H is the same distance as A to H. Yeah? So we don't even know what those distances are, but we know they're the same. Why? Because we use the same opening size on our compass. Yeah? Okay, let's do this one more time. This time, let's go really kind of close to halfway here. We know it's not going to work less than halfway, right? Because our arcs wouldn't cross if I had one over here, but it's got to be more than halfway. Let's do another perpendicular bisector construction right there. Okay. You should have come up with, again, another set of crossing arcs on the same line, right? All right. And again, we're going to label these. This time we're going to call this one D. We're going to call this one G. And what do we know? Well, whatever the distance is from A to D, we use the same distance to go from B to D. And likewise, down the bottom here from B to G, it's the same distance from A to G, right? So here's the deal. Have you noticed that every single point along this bisector line at 90 degrees is the same distance from the ends of the line segment? No matter where we are on this line, pick a point anywhere on here, it will be the same distance in a straight path to the two ends of the line segment. That is the perpendicular bisector theorem. So let's write it down. I'm going to zoom in a little bit here so you can see my handwriting. Okay? So here's your perpendicular bisector theorem in words. We're going to say if, double underline, a point is on the perpendicular bisector of a segment, then double underline, that point is equidistant from the end points of the segment being bisected. So if you have a perpendicular bisector of a line segment, which is what we create with these crossing above and belows, any point on that line is going to be equidistant from the two endpoints of the segment that's being cut in half. Like, for example, the distance from A to F is going to be the same as the distance from B to F. Or we could say the distance from H to A is going to be the same as the distance from H to B, etc. Because there's a lot of different examples that we could put on there. Those line segments are the same. They're radiuses of a circle. That's important to know. There's one other thing that's important to know about this. This statement is what we call biconditional. Should have double underlined that word. That's an important word. It's biconditional. I'm gonna farkify that for you just a little bit. Okay? That means that we could travel the other direction on the same sidewalk. We can travel the other direction on the same sidewalk. Let me show you what I mean. Watch this. Everybody looking up here? Here's the perpendicular bisector theorem. If a point is on the perpendicular bisector, it's going to be equidistant from the two endpoints of the line segment being bisected. If a point is equidistant from the two endpoints of a line segment, it must sit on the perpendicular bisector. See how I flip-flopped that? I turned around and walked the other direction on the same sidewalk. And that's going to allow us to use this tool in multiple ways, right? I want you to think about what we've done so far today. We've taken this tool and we've done this little construction that allows us to find the middle of a line segment and draw another line through the middle at 90 degrees, right? Well, what if I wanted to draw a line through this point at 90 degrees that's not in the middle? Go ahead and turn your paper over and let's do that one. Okay, so take a look at this first question up here in the upper left corner, back side of your paper. Now what we want to do is we want to draw a perpendicular line to the original line segment, but we want it to go through this point right here. Now think about what that's going to look like visually, right? Visually, that's going to be like a line that goes like that, right? It's got to go through that point at 90 degrees. The problem is we can't do that, start at one end, arc above, arc below kind of a thing, because we're going to get a line that's going to go through the middle, and we don't want it to go through the middle. We want it to go through here, right? But the question is can we manipulate our tool a little bit? And the answer is yes. Okay, watch. I'll show you what to do. Let's put our compass pointer right there on that point where we want to draw our line through. And then let's set our compass opening. So loosen up your compass a little bit. Let's set our compass opening just so it comes in like the end of that starting line segment, right in there. All right, now, watch what I'm going to do first before you do it, okay? I'm going to draw an arc through this side of my line segment like that. And then I'm going to swing my compass around over here, and I'm going to draw an arc through this side of my line segment like that. See what I did? Arced on one side, and I arced on the other side. Now, just for visual purposes, let's do some dashes along here with our compass. Like that. Okay, see the dashes I did? Now watch up here. What I've done is I've created a circle around that point that I want my 90-degree line to go through, right? Now think about this for a second. That's a radius right there. And so is that right there. Which means that that point is equidistant from the two endpoints of the circle here and here. So if I consider a line segment that runs through those two intersections right there, and I take my compass opening and I start with my pointer on one side of the circle and I open my compass more than halfway, I can go even larger than halfway, and I arc above and I arc below. And then I switch my pointer over to the other side of the circle here, and I arc above, and I arc below. I'm gonna go right through the middle of the circle, which is the point that I wanted to draw my line segment through. And so then I can come over here and I can line up my pencil. And draw my line. And I just created a line segment right through the point that I wanted. And if I check it, right at 90 degrees. Pretty cool. Now we can drop a 90-degree line through any point, anywhere on a line segment. It doesn't just have to be the middle. We just make a new middle out of it by creating a circle around the point that we want to draw the perpendicular line through. That's kind of interesting, huh? Yeah. Okay. I can come take a look in a second. So let's talk about the second example here. Okay? So in this second example here, we want to drop a 90-degree line through this point right here. That's going to be pretty hard to do with our compass, huh? Because we don't have a whole lot of space to work with, do we? But what did I say yesterday was okay to do if we needed it in order to like make our constructions work? Like putting a 1 underneath a whole number if we got to do fraction work. What did I say it was okay for us to do? What's that? Yeah, we could extend our line, right? We could give ourselves a little bit more working line, right? So let's do that. Let's take our ruler and let's make sure it's lined up here with our original segment so that when we draw it, it draws correctly. And then we can just give ourselves a little bit more room to work. Okay. Drop yourself a 90-degree line through here. Now here's what I want you to do though. Okay, watch carefully real quick. I do not want you to do the whole circle here. I just want you to do the arcs on either side of the center of your imaginary circle there. So we're not doing the dash circles. We're just doing the side arcs. Okay, let's see if you can get it and make it look right. Go for it. All right, here's what you should have come up with right here for that line segment. Again, you got your crossing arcs, which puts your point at the center of a new circle, even though we don't draw the whole circle. And then we just open our compass more than halfway. We arc to one side, we arc to the other side, we flip it and do that again. And we get our 90-degree line right through the point that we want. How's that work? Make sense? Everybody good?
Do we have to draw the box?
Yeah, you want to put that in there to indicate it's a 90-degree marker. That way you know that it is. Okay. All right. I want you to do the next two constructions on your paper. So you're going to do this one here and this one here. I want you to drop 90-degree lines through those 2 points right there and there. And I'm going to come around and check and see how you're doing. All right? Go for it. Yeah, 90-degree lines through that point and a 90-degree line through that point. Feel free to extend your line as needed. All right? Look like that right there.
Is it okay if they're a little bit bigger than that?
Yeah, that's fine. Yeah. As long as you have your crossing arcs and your 90-degree line through there, you're good. Okay, cool. All right then, let's talk about what are we going to do in a situation like this one. Now our point is not on the line, and yet we want a 90-degree line to travel through both the point and the original segment. Okay? Again, another manipulation of our tool comes in handy. Let's do this. Let's give ourselves a little bit more line to work with here. Just so that we are in good shape. So I'm going to give myself a little bit more room on the left there. So I just extended my line a little bit here to work with. Okay, now remember, the perpendicular bisector theorem says that if a point is equidistant from the endpoints of a line segment, it must sit on the perpendicular bisector of that line segment. So really, if we could figure out a way to make this point right here equidistant from this line segment in two different spots, then we would know that it would sit in the middle of that. And we can do that by just taking our compass pointer and setting it right here. And then what we're going to do is we're going to create an arc through our line here, like that. And then I'm going to come around over this side, and I'm going to create an arc through my line here, like that. What is this measurement right here? It's a radius, huh? And what is this measurement right here? That's also a radius. Let's do some dashes just so we can see the invisible circle here that we're not actually going to draw every time, but we're just going to put some dashes in so we can see the invisible circle, right? But the idea of this is that this distance is the same as this distance, which means that this point right here sits directly in the middle of a line segment that runs from those two arcing intersections right there. So then all we should have to do is set our compass point at one of those intersections, make sure we're open more than halfway. We can arc above. We can arc below. And then I can switch to the other intersection that's equidistant. And I can arc above. I can arc below. And when I line up my two intersections, and all I need are my two intersections, I get a 90-degree line through a point out in space back to a line segment. It again comes down to the idea of making that point the center of a new circle. So whether that point sits here or on the line, we're creating a new circle around it, making it the center, and then we're using one of the measurements of the edges of the circle, the distance in between two radiuses, to then bisect that and create this perpendicular bisector line. Okay. Questions? You think you can do this one? All right, let's see what you can do. Go for it. Does yours look like mine? It does? Wait, what's different about mine than yours?
You only have one X.
Yeah, I only have one crossing intersection. But I've been saying all along, oh, well, you got to have two crossing intersections so you can draw your line. Two crossing intersections so you can draw your line. So then why do I only need one here?
Because the point can be the same point.
This point right here has to be on the perpendicular bisector line, right? And so this would be another point on the perpendicular. And I only need 2 points to make a straight pathway. And as you get to your project, you're going to have a lot of constructions on one picture. You want to try to keep it as clean as possible. And so in this case, instead of adding another set of arcs up here, I didn't need that because I knew it was going right through that point anyway, because that point must sit on the perpendicular bisector line. I can just use that point and my intersection. Okay? So on your next two constructions, I want you to try to do it with just one set of crossing arcs and your point. I'm going to tell you this, though. Do your crossing arcs on the opposite side of your line segment than your point. Okay? Do your crossing arcs on the opposite side of your line segment than your point. Okay? You're going to do the bottom two constructions, all right? Bottom two constructions right here. You're going to do these two constructions here. Okay? Ready? Go. All right, last one should have looked like these right here with one set of crossing arcs. All right, You have some very valuable skills at your fingertips now. You can bisect a line segment. You can drop a 90-degree line through the midpoint. You could drop a 90-degree line through a point on a line segment anywhere. Or you can drop a 90-degree line from a point out in space back to a line segment. A lot of things with the same construction. As long as you know how to manipulate that tool, you can do a lot of different things. Okay? Questions? Everybody good? All right, let's do some homework.